So on this one, you're supposed to draw 3 cards off a well-shuffled deck, a normal 52-card deck. What's the chance of at least 1 ace? So anytime you see this, the probability of at least 1 ace, okay, that's supposed to clue you in that you should be using the complement rule as a shortcut. Because you could go through and you could say, well, what's the chance that like my first card is an ace, but my next card is not? Or my second card's an ace, but the first one's not, or maybe they're all aces, or the first 2 are aces, or the second 2 are aces. There's just so many possibilities of when you could have an ace. Okay, so what we're going to do is use the complement rule. So the probability of at least 1 ace is going to be equal to 1 minus the chance, or the probability, of no aces. That's always the case with the complement rule. This always works. Probability of at least 1 is always 1 minus the probability of no. Almost guaranteed to always show up on any exam because it is such a useful trick. Okay. So what we need to do is we just need to find the probability of no aces. So to get no aces, you'd have to get a not ace first, and a not ace, and a not ace. You have to have 3 not aces. So let's figure out what that would be. So to get a not ace first, well, in our deck there are 52 total. There are 4 aces, and there are 48 not aces. So the first time I want to get a not ace, I have 48 to choose from out of a total of 52 cards. But then when we're playing cards, we don't usually put the card back. It's almost always without replacement. So now I want to get another card that's not an ace, but I've already used 1 not ace. So there's only 47 not aces left and only 51 cards total. And then again, I want another not ace, but I've already used one. So there's only 46 left out of 50 total. So you'll just put this into your calculator, 1 minus all of that, and that will be the probability of at least 1 ace.